All right, welcome to 6 p.m. and the last talk of the day for track 2. We got Brett Hawkins applying the InvisibilityCloak, obfuscating C# tools to evade signature-based detection. Brett is he's been in information security for a while now, working for multiple Fortune 500 companies across different industries, currently on the adversary simulation team at X-Force Red at IBM. He's got some certifications. He's spoken at conferences in the Midwest, apparently DerbyCon, Hackers Teaching Hackers in Columbus, and B-Sides Cleveland. Also a member of the open source community, contributed to lots of projects you're probably already using. His knowledge and experience and breadth of information gives him a unique and well-rounded perspective that he's going to show off right now.
Thank you very much. Thank you. All right. So for those that are here physically, thanks for delaying your dinner tonight to come see the talks. I appreciate that. For all those watching virtually, thank you for joining in. So my talk, applying the InvisibilityCloak, obfuscate C# tools to evade signature-based detection. So as you mentioned, my name is Brett. I'm on the adversary simulation team at IBM X-Force Red. We typically do like red team type of engagements, so long-term 2-3 month type of engagements for typically pretty large clients, both in the public and private sector, focused on getting access to kind of an organization's kind of crown jewels while, remaining stealthy, not being detected. Prior to X-Force Red, I was on the Mandiant Red team doing adversary simulation and also network pen testing for a while. Prior to that, I was on the adversary simulation team at JPMorgan Chase. And then prior to that, I was at the James Smucker company where I did both kind of blue team type work, like I was in a SOC, and then also did network penetration testing. As far as stuff outside of work, what do I like to do? Big sports fan. So I'm from Ohio. So I really like the Cavs basketball, Browns football, Buckeyes football, that type of thing. Really like playing Xbox. So our team really likes to play Halo a lot, so play quite a bit of Halo together. Also really into barbecue smoking, so I have a smoker at home, so really into smoking pulled pork, brisket, stuff like that. Really into that when the weather is actually nice in Ohio, which is not very often. So one thing I like to ask whenever I go to talks and stuff is I always how did they come up with this? How did they come up with this research, this idea? This specific research, one of the main reasons was just advances and improvements in security products and configurations over the years. So specifically with .NET Tradecraft, 5 years ago, it wasn't very good at all. But products, a lot of security companies are really upping their game, which causes us as offensive security practitioners to also up our game. Second reason for this research, there are cases. So with our team, for example, private tooling is king, but there are cases I'll get into in a second where you want to use public C# toolkits and you want to use those for activities without detection, whether you're running them on disk, dropping them to disk, or you're running them in memory. We need to be able to use these toolkits and we need to be able to use it, like I said, without getting detected. This talk is for everybody. Ted Lasso, it's for everybody. So whether you're on offense, whether you're in defense, so obviously if you're on offense, whether you do pen testing, anything like that, you're going to get a lot of this, a lot of practical usage, obviously, out of this talk. Defense, you're going to get a lot too. So you're going to see maybe how brittle some of these signatures can be for some of the tooling that is out there. So this talk is really for everybody. And because I started out on defense, I kind of always have kind of that defensive hat on. So that's kind of the scope that I usually go with whenever I'm doing anything offensive. I always think about the defensive side as well. So as far as the agenda, I'm going to go over a background on kind of, C# tools that are out there. And then also I'm going to go over kind of what the kind of security control landscape looks like for C# tools. And then I'm going to go through some different static components and C# tools that you can use to build a signature-based detection. I'm going to go through changing those static indicators manually. And then I'm going to go through automating changing those indicators in the tools with a tool I wrote called InvisibilityCloak. I've got some demos put together. I've got 5 demos put together for you guys. Demos should be pretty cool. Hopefully you guys enjoy them. I'm going to wrap it up then with some defensive considerations and then a conclusion. So let's go over the background here. So as I mentioned, there are reasons that you want to use public C# tools. Private tooling is king, but there's a couple primary reasons to use public tools, in my opinion. The first one, so every team, right, you have a finite amount of time and resources. You have different priorities. You don't always have time to develop some sort of functionality or some type of capability in-house, right? So your priorities are doing other things. So public tooling is really good for being able to take advantage of the kind of that capability gap you have, right? Second reason is really around, creating a private tool is not going to give you any benefit compared to like the public tool. So for example, rather than build your own Kerberos-based attack tool, why not just Rubius? You're going to be reinventing the wheel, right? So those are really the two primary reasons, right, in my opinion, for kind of using public tooling. I've listed 4 kind of popular, public tools that are out there in C#. I've got some slides later on where I actually ran InvisibilityCloak against like 20 different tools. I'm going to go through some of those, but for these here, so like Rubius is obviously a popular public C# tool for doing Kerberos-based attacks. You've got Seatbelt there, also from the folks at SpectreOps for doing situational awareness on Windows hosts. Also another tool, stand-in that's out there. So Ruben Boonin on the X-Force Red team wrote this. So it's a really nice tool for doing Active Directory recon and some attacks. And then lastly, a tool I wrote while I was at Mandiant, SharpPersist, another one that's out there for doing like Windows-based persistence, both kind of user land and then also kind of like admin level persistence. In terms of like security controls for C# tools, I kind of just break it into 3 buckets. So you've got the signature-based detection on disk, which is like your typical like antivirus type of thing. Then you've also got the signature-based detection in memory. So this was something, I don't know, the last few years this came about with AMSI for .NET. This was kind of a game changer from a defensive standpoint, because a lot of the times, like on our ops, we're operating in memory on systems with like, for example, Cobalt Strike, a Poplar C2 framework. So when we're actually running these tools, we're not like dropping them to disk, right? We're going to be running them in memory, reflectively load into a process, right? And run those. So what AMSI for .NET allowed like, Windows to be able to do is analyze those .NET assemblies that are being ran in memory. So this allowed, gave the capability to, instead of just doing detection on disk, also having detection in memory. So that was really a game changer. And that was one of the main reasons, us as kind of in the offensive security industry have had to step up our game, because of how detections are, how much better detections are getting in memory. And then lastly, enhanced telemetry. So the more telemetry, the better. So with event tracing for Windows, ETW, that's also been really good in terms of security controls. Again, if these are kind of the 3 buckets that I kind of divide these out into in terms of security controls for C# tooling. So let's go through some different static components in C# tools that you could use and need to be aware of in terms of what could be used to build detections. First one, and this is not a very good one, tool name, right? So name of tool can be used as a signature. I have seen this before. This is obviously not a very good control, not a very good signature. So for example, I have safetycats.exe there, which is a tool from the folks at SpectreOps as well. And I'm just renaming it to totally not safetycats. Again, not a great standalone detection. Something that's a little better is the project GUID. So in Visual Studio, like when you have a C# project, each project is assigned a unique GUID. So for example, if you pulled down the seatbelt project, made some changes to the code and then recompiled it without changing that GUID, it's still going to have that same kind of unique identifier, right? They're unique identifiers for a project. So this is a little bit better, but again, those things can be changed. So the screenshot there on the top, you can see I'm just looking at the project GUID, for example, for the seatbelt project. And so when you would compile seatbelt and then run a strings on it, you would actually see that GUID right there. It's, again, that's going to be in the compiled tool. There's a really great resource from Brian Wallace, the link there, basically talks about using .NET GUIDs to help hunt malware. PDB strings are another piece, a static component you could use. So, or programmable database file strings. Now, these can give really good descriptive names about where tools are compiled. And the folks at Mandiant, actually, there's a great blog post here from Steve Miller when he was at Mandiant, talks about how they actually use the PDB strings in terms of like tracking, APT groups to help them kind of attribute malware and such. So in an actual Visual Studio project, if you actually open your project, look at the projects, the build settings, you're going to see this PDB only. And so that's kind of what's, whenever you compile it, that PDB string is going to be in the tool. So for example, in this case, we have sharp view, compiled sharp view, and you do a strings on sharp view, you're going to see that PDB string where the tool is actually compiled. And I'll show you in some later slides how to turn that off so that the PDB string is not in your tool when you compile it. Variables and method names are also really good for kind of static indicators. So if you look in the slide there, you can see we have the safety cats project open, and there is a variable named compressed mimicat string in one of the class files. So that's just another kind of static indicator you could use. Method names. We have the sharp view project open. There's a method there called find interesting domain share files. So again, another component that you could use really for all these things. It's not about just using one. It's about putting all of them together to actually build that really good, like kind of signature-based detection for a tool. Strings and classes. Strings are really good, a really good static indicator. So you can see in the safety cats project, it's got that compressed mimicat string, compressed mimicat string variable assigned to this string here. What that string is basically it's like mimikats piped through out compressed DLL, and then you have that string there. Basically, all safety cats is just a C# wrapper to load mimikats essentially. So this string here is not gonna change. You can change it, but it's a really good static indicator. And in lots of tools, strings are really great opportunities for detection. One thing that I do in my tools now is I actually don't, like for my C# tools, I don't put a help menu in there. I just kind of say like see, the documentation, because help menus have tons of strings in them. Yeah, it's good to give users switches and stuff, but refer them to the README instead, because the more strings, the more opportunities for building like a signature-based detection. Class name. So we have the seatbelt project open there. Seatbelt.cs, seatbelt argument parser. Anything kind of with the tool name there. Classes again can be just another piece of that puzzle. However, they're static, right? So you can obviously change them, right? So let's actually go through looking at these static indicators, these different things, PDB strings, classes, and stuff like that. And let's go through actually kind of changing those manually. So string manipulation. I mentioned strings are a really great opportunity for detection. So I'm going to go through 3 different string manipulation techniques. These are like, really, really basic. There's tons of different ways that you can manipulate strings. You can encrypt strings and stuff like that. I'm going to go through 3 of them, and these 3 are in InvisibilityCloak. You're going to see in later slides. So first one, ROT13. It's just a simple letter substitution cipher for A through Z. So if you can see the screenshot on the left, I'm taking this string, testing this, and I'm rotating each letter by 13. So T goes to a G, E rotates to an R, S rotates to an F, and so on and so forth. So I'm taking that original string, I'm obfuscating it to have this obfuscated string with ROT13. And then in the screenshot on the right, I'm taking that obfuscated string, I'm deobfuscating it at runtime and to get the original string here. Base 64, so this is something that's very popular, obviously, in InfoSec, whether you're on offense or defense. You take a ASCII string and you put it into its radix 64 representation. So screenshot on the left, I have Python. I have that testing this string. I'm base 64 encoding it to get this encoded string. Screenshot on the right in C#, I'm just taking that obfuscated string, that base 64 encoded string, and then I'm decoding it at runtime to get the original string. The last one here, and this is really my favorite. This is my favorite method in InvisibilityCloak for a couple reasons I'll get into later. But this one, reverse string. So just take a string and just reverse the order. This works really great wonders for string manipulation and in terms of evading kind of signature-based detections. So the screenshot on the left, I have that testing this string, and I'm just simply reversing the string. So you can see here, like the explanation point is at the beginning. And then the screenshot on the right, you can see that I'm taking that reverse string and then I'm putting it in the proper order at runtime to get the original testing this string. So again, these are just 3 different string manipulation methods. There's tons of different ways you could manipulate strings, but these are 3 kind of really basic ones that are very effective and don't increase the file size as significantly as something like encrypting strings. The project GUID I mentioned, each C# project is assigned like a unique GUID. So if you want to generate a new GUID to put in your project with just a couple lines of Python, you can see there in that screenshot, just generating a new GUID. Now, once you have that new GUID, there are 3 files that you need to place the new GUID. The first one is going to be your Visual Studio solution file. So you'll want to make sure that you place the new GUID in there. Additionally, the C# project file, you're also going to make sure that you replace the GUID in that. And lastly, on the screenshot all the way on the right, the assembly info.cs file, you want to make sure that you replace the GUID in there as well. Tool name. So again, 3 spots you got to change the tool name in. The Visual Studio solution file, so you can see there on the top screenshot, changing it to some new tool. And what we're actually doing here, the project that we're modifying is the stand-in project I mentioned earlier, which was written by Ruben Boonin. And then you also need to change it, the C# project file. You need to change to the new tool name. And lastly, the assembly info.cs file, you also need to change the tool name. Also, just make sure you change the file names of like the C# project file and Visual Studio file as well to your some new tool. And then lastly, you've got all this stuff changed, the C# project file, you've got the tool name change in those 3 files, and then you can just compile it. And you can see here, this is no longer stand-in. This is just some new tool name that you have here. So it's your new tool. And then the last thing too are the PDB strings. So I mentioned in that window in your project, it's going to have that PDB only. So what you can do is in the C# project file for your project, you just simply change that to none. And then you can see when we're running strings on our compiled tool, you're not going to see the PDB string there. So this just kind of went through manually. So we went through, these are the different static indicators that could be used for detection, like in your tools or in the public tools that you're using, and then going through manually changing those static indicators. So I started thinking about this. I was like, okay, I can do all of this manually, but I don't really want to have to do this manually every single time for a public tool that I want to use. So I started thinking about, like, could this be automated? And that's where InvisibilityCloak came about. So InvisibilityCloak, also, yes, I'm a huge Harry Potter nerd. So this is definitely a play on the movie, Harry wearing his invisibility cloak there. So that is where I got the name from. It's a proof of concept obfuscation toolkit for C# tools, changes the tool name, changes the project GUID, removes the PDB strings, and then obfuscates strings as well based on the method you give it. I've got the link posted there on the X-Force Red GitHub page. Before this talk today, I actually posted the slides and the demos I'm going to go over. So if you want to, pull, after when you get home from the conference, whatever, want to take a look at them, feel free. They're up there on the repo. I've also got a blog post that I wrote, kind of going through some of the things I'm talking about today, different static indicators, manually changing them, and also a few things on InvisibilityCloak. So definitely check those out. With this tool, there's 3 main goals in terms of obfuscation that I was thinking about. The first one is you want to maintain the integrity or the functionality of the tool that you're obfuscating, right? You want to have the tool actually do what it was originally designed to do. So if you're obfuscating a persistence toolkit, like, you don't want it to, you don't want it to not work, right? That kind of defeats the purpose of doing the obfuscation. And in terms of like string obfuscation, you want to provide, I wanted to provide as much coverage for as many strings as I possibly could without breaking the tool or not being able to compile it. Because the last thing you want to do is you want to, run it through obfuscation, and then you've got a bunch of errors you got to figure out manually, right? So there's really a balance there, and obfuscating as much as you can for, as much as you can. And really with C#, not all strings can be dynamic. Some strings have to be like a static value. So for example, if you have like a a method header, and one of the variables for the arguments, you want to have like a static string in there. Like you can't have that be like some sort of dynamically generated string. And then the last one specifically was around file size. So Cobalt Strike, which they recently just increased the limit, but in terms of running .NET tools in memory, they had a 1 megabyte limit. So if your tool was over 1 megabyte, you couldn't run it in memory. So with obfuscation, you're transforming like strings, you're transforming strings. And when you do that, it's going to make the tool bigger, right? So it's about managing that file size as well. So those are the 3 goals that I had in mind when I was trying to write this tool. There were challenges. It definitely was not easy as I thought it was going to be. It took longer than I thought it was going to take, and I'm continually refining it. First thing is, like I mentioned, there's many different ways to specify and use strings, and if you can imagine all kind of the different C# tools that are out there, everybody has their own way, like they like doing things, right? So that was definitely a challenge. I tested against like 20 different projects that are out there, and then another challenge was around evading signatures in method or variable names. So it's currently in the tool, it does not obfuscate method names or variable names. And you're going to see that here in the demo. So still trying to think about how to do that. Definitely a pretty big task to do that and not break things. So those are the two main challenges kind of with this project. So let's kind of go through kind of actually using it. So for example, obfuscating kind of a well signature tool, the KRB relay up tool, which I think everybody's pretty familiar with now after just being released for 2 weeks. So here's an example of me running InvisibilityCloak on KRB relay up. So not sure how quite you can see that there in the back, but you can see here we're providing it the directory where the Visual Studio project is. So it's going through, right? It's changing the project GUID. It's also going to remove the PDB string. And then it's also going to go through and obfuscate strings in each of the C# class files. And then you can see on here after running it, our new tool is called Let's Go Up, and you can see that tool right there. So now if we actually take our new KRB relay up tool that's called Let's Go Up, we're going to use Defender Check in this example, which is a tool wrote by Matt Hand at SpecDrops, and it's basically just kind of a wrapper around like Defender, so you can like scan a file and say, hey, is this file detected, and what are the offending, the signature for it. So you can see here, I'm running Defender Check against KRB relay up, and this was like probably like, I don't know, not long after the tool was released, but obviously. The KRB relay up tool, if you're not familiar, it's kind of a local Windows Priv-esque tool that was released. It's gotten a lot of attention, and because of that, obviously once the tool is public, signatures are built. So I'm running Defender Check, and you see there it has some detections around that, and then you can see me running Defender Check against the version of KRB relay up that went through InvisibilityCloak called Let's Go Up, and you can see here that it's good to go. Right. So just after, and I just did this last week, I think it was. Yeah, worked just fine there. Also, in terms of like signatures in memory. So I mentioned AMSI for .NET was kind of like a game changer. I'm running the tool stand-in here in memory. So this first run here is me running stand-in with Cobalt Strike's execute assembly. This is the one straight from the GitHub page. And you can see here, I get this error message, failed to load assembly with this error message. And what that is that's actually AMSI for .NET picking that up, and you can see the details right there. So then I'm taking a version of stand-in called stand-up that I ran in through InvisibilityCloak, and you can see that I was able to run that no problem. It got past the signatures that were there. So as I mentioned, I took 20 different kind of public tools that are kind of popular out there to actually run InvisibilityCloak through and do testing. And for the most part, all these that originally were detected, running through InvisibilityCloak gets them past the detections. And this is specifically for Microsoft Defender. This is the free version. And this was ran on April 14th. So obviously things could have changed since April 14th. But as of April 14th, specifically with Microsoft Defender, the free version, these were the stats. Now, these two problem childs here, Rubius and Sharp RDP, I'm going to show you how to get around those in the demos. So after running through InvisibilityCloak, there's like one tweak you have to do to get it past Defender free version. So I thought these statistics were really interesting. There's a lot of really great tools out there. You can see me. This is obviously an exhaustive list of all C# tools that are out there. These are just ones that are popular that I'm pretty familiar with. I know some of the authors of these as well. I see in the audience. So but yeah. So these are just some really good ones to test against that have kind of signatures in place. Another thing I found interesting was the compiled C# tool size. So I mentioned in my 3 kind of obfuscation goals that file size is one of them. You want to obviously provide the obfuscation, but you don't want to increase the file size too much, right? That you're not going to be able to run through execute assembly. So in InvisibilityCloak, there are 3 different string obfuscation methods. There is ROT13, base64, and reverse string obfuscation. And if you look at some of the stats there quickly, you can see the method that increases the file size the most in general is going to be the ROT13. And the one that is going to increase the file size the least is reverse string obfuscation. So in the example, for example, of like Rubius, Rubius unobfuscated is 418 kilobytes. When you run it through ROT13, it's going to go up to 605 kilobytes. Compared to like reverse string obfuscation, it's just 455 kilobytes. Seatbelt, right? Seatbelt's probably the biggest jump. So seatbelt unobfuscated is 543 kilobytes. And you can see running it through ROT13, it jumps way up to 904 kilobytes, right? So that's a pretty big jump. It's still under 1 meg, but that's a pretty big jump compared to like the reverse string obfuscation just increases it to 608 kilobytes. So there are some file size differences between the 3 different methods. And so I just wanted to make sure that, I found it interesting in terms of the file sizes. And really what's this is going to be dependent on is like the number of strings. So the more strings obviously get obfuscated, like the difference is going to be bigger between these different methods. There are alternative options, if I could talk, to obfuscation, to InvisibilityCloak and also obfuscation. So in terms of obfuscation, Confuser X is a really good tool that's out there for doing obfuscation. InvisibilityCloak is more of like a pre-build obfuscation. So you're obfuscating the tool before you build it. Confuser X is like a post-build obfuscation tool. So after you built your tool, you'd supply it like your compiled EXE, and then it would do kind of like a post-build obfuscation on it. Obfuscator is another good project from Flangic at Trusted Sec, and basically this is another really great obfuscation tool for .NET tooling. An alternative to obfuscation, if you don't want to do obfuscation, is you can simply disable AMSI or disable ETW. Those 2 buckets kind of I talked about. Really great tool here. Inline execute assembly. Sean Jones at X-Force Red wrote this. You're going to see this in the demo, but basically inline execute assembly allows you to run a .NET assembly in your own process compared to like execute assembly in Cobalt Strike. It's like a fork and run. You fork a process and run another tool, or fork a process to run your tool. And it's got the capability to disable AMSI and ETW. And then inject ETW bypass. This is from Bobby Cook, who's also a member of the adversary simulation team at X-Force Red. He has an inject ETW bypass tool that kind of gets around ETW. So here's just kind of showing a screenshot of running inline execute assembly, and you're going to see this in the demo. On the top there, we're running Rubius straight from GitHub, and you can see here that we're getting that failed to load assembly message, which is again AMSI for .NET picking that up. And then we're running the exact same Rubius tool. Again, this is straight from the GitHub page with inline execute assembly, but we're passing in this -- AMSI flag, which disables AMSI. And you can see here that we're able to run the tool just fine. With that, I've got 5 demos here to show you. Not 4, but 5. All right, cool. All right, so this first demo, I'm going to be running InvisibilityCloak through stand-in. So I'm going to start this video here. So we're going to run this through stand-in, and then we're going to show kind of the static signature detection with the defender check. So first thing I'm doing here, I'm just opening the stand-in project kind of before the obfuscation, just to show you that this is the original project, just to kind of show you everything is looking normal before we actually run it through the obfuscation. As you can see here, we're just kind of running through just to kind of show you, okay, this is the normal project. All the strings look like normal strings. They don't look like gibberish just yet. So then what we're going to do is we're going to take InvisibilityCloak, and then we're going to feed the stand-in project to it. Okay. So we're going to give it the directory where the solution project is. We're going to give it our obfuscation method, which is going to be reverse, and a new tool name of stand-up. So you can see here, I'm going to highlight that it's generating a new project GUID. It's going to place it in those 3 files I mentioned: the solution file, the C# project file, and the assembly info file. It removes the PDB string from the project file. It renames any class files that have the original tool name in it. So you can see we're renaming hstandin.cs to hstandup.cs. And then lastly, it's going to go through the class files, any class files, and do screen obfuscation. So this project only has 2 class files. So it's just going to obfuscate the strings in those 2 class files. You can see here we have our new project there. So stand up. And we're going to open this project, and you're going to see the difference in these strings. All right. So I'm going to open this up, and things are going to look a lot different, right? So we're going to open this project. Obviously, the strings look way different. Ran the reverse string obfuscation, so all these strings are replaced. As you can see there, we took the original string, reversed it, and then kind of put a method after that. So all these strings are, what's going to happen though is at runtime, these strings are going to get deobfuscated at runtime, and they'll just be like normal, and the tool function just like normal. So you can see here, obviously, it looks a lot different. So what we're going to do is we're going to go ahead and build this project, clean solution, and rebuild. And then what we're going to do is we're going to take this newly obfuscated stand-in tool, and we're going to run defender check against that and run it against the original stand-in to make sure that we get past the static signatures on disk. So we're going to take these 2 files. Right, take our stand-up tool, and so you can see, obviously, the file size is going to increase a little bit from 162 kilobytes to 189 kilobytes in this instance. So we're going to run defender check against the stand-up. So this again is stand-in ran through InvisibilityCloak, and you're going to see here it's going to come back. We're good to go. Good to use the tool, and then we're going to run it through the stand-in straight kind of from the GitHub, and you're going to see it's going to have some offending bytes here. So sorry, Ruben. Yeah, so come back here. Yep. All right, so you can see there, obviously it does have a signature, but you can see running it through InvisibilityCloak got us past that. Now the second demo, I mentioned in that table that there were 2 problem childs, all right, running InvisibilityCloak. So Rubius was still getting detected by Defender, the free version, and so is Sharp RDP. So I'm going to show you how to get past that. So we've got the Rubius project. Again, just going to kind of open it real quick here to show you, it's the original the kind of original project before all the string obfuscation. So I'm going to just kind of forward through this here. So yeah, you can see here, something I do want to pause though. There are some strings that are not included in obfuscation. Really, were just kind of edge cases that I came across in testing. One of those problem childs were regex strings. So if a line has regex, like a regex string on it, it's not going to obfuscate that regex string. So in the GitHub page, I have a list of like the strings that are not obfuscated, but those were kind of one of the edge cases I came across. I'm sure we'll be able to figure out here soon, but just one of the edge cases I came across. So we're going to run InvisibilityCloak against Rubius here. And again, what I'm going to show you is that running through InvisibilityCloak is still going to get detected by Defender, but then I'm going to show you one manual modification you have to make after doing that to get it past Defender. So again, just like the last one, it's going through, generating the new project GUID, putting in those 3 files, removing the PDB string, again, runs all that, goes through all the class files, does the string obfuscation, goes through everything. A lot more class files in this project, obviously, but it still runs pretty quick, as you've seen. So we've got our new tool, which is Hello WWHF, Hello Wild West Hackin Fest. And so what we're going to do is we're going to open our new project and we're going to compile it. All right, so we're going to open this up, and it's obviously going to look a lot different. You can see there the strings are reversed. And I also want to pause this here. It also, any strings that have the original tool name in it, it will rename. So this string that is right there, it originally was unhandled Rubius exception. It is now unhandled hello Wild West Hackin Fest exception. So then we're going to open this Kerberos class right here because I want to show you what I was talking about with some strings aren't obfuscated. So we're going to scroll down to the line where the regex was. And you can see there, whoops, right down there, that, let me write this. Yep, so you can see that highlighted. So that line was not obfuscated because of the regex being there. Again, this is just an edge case that I came across in testing against a bunch of different tools that are out there. So we got our newly obfuscated code. We're going to go ahead and rebuild the project. And then we're going to take a look to see if this gets past Defender, which it's not going to. Spoiler alert. And the reason for this, as I mentioned, method and variable names, I'm not obfuscating or like randomizing in InvisibilityCloak. And specifically with Rubius, you'll see the signature that I missed that I didn't cover was around a variable name. So we're going to run Defender check against the original Rubius, and obviously there's going to be a signature for it. And then we're going to run it through our hello Wild West Hackin Fest tool. And you're going to see that there's still going to be that same signature with the kind of get underscore tickets, and I'll explain that in a second. It's going to come back here. It's going to have the same signature. So get underscore tickets. What that is, that's a get method for a tickets variable. So what we're going to do is open up the project here. So you can see that's still there again. I don't obfuscate the variable names right now. So we're going to search in the project for any occurrence of tickets, a get method for a tickets variable. And it's going to come up with a couple hits. So this is additional tickets, so not that one. We're going to search for the next occurrence. So there's going to be two occurrences, right? So you can see there, we're going to rename that simply to, I think I did something else, maybe. We renamed it to something else. Yeah, some other thing, right? So we're renaming it to some other thing. So that's renamed. And then there's going to be one other occurrence of this get method for the tickets variable. We're renaming that. This one I renamed to something else, I believe. Yes? All right. And then we're going to recompile the tool. Any guesses on whether this gets past Defender? I already spoiled it. Yes, it does. Wrong, sir. So yeah, we got that here. We're going to run Defender check against it. Copy this over. Again, the file size didn't jump too much with the reverse string obfuscation. All right, so we're going to run Defender check against it. Good to go. All right, we're all good. Sharp RDP, this will be a quick one here. This was the other problem child that we have to address here. So this one has a signature in a method name, specifically with this tool. So we're going to run InvisibilityCloak through Sharp RDP. And it's going to go through and do its thing, just like I showed previously, go through, generate a new GUID, do all that good stuff. We're going to call this pass the remote is going to be our new tool. So Sharp RDP is now pass the remote. And so we're going to go ahead and compile this tool, and we're going to run Defender check against it to see where the remaining signature is that we need to change. So we've compiled the tool here. We're just going to copy it over. So you're going to see here again, it's going to still have a signature for this tool, and it's going to be in a method name that we'll find out. So if we look at the end of that signature there, send text. So we're going to take send text and we're going to search it in the Visual Studio project. And you're going to see here that it's actually a method name. So you can see there, send text. So we're going to go to where that method's defined, and we're just going to rename it through the whole project. So we're just going to right click on it, do a rename in Visual Studio, such a great IDE. And then we're going to rename it here. And then we'll recompile the tool. All right, you see there's obviously no more occurrences of send text, so we should be good to go. Go through, these are just warnings. Still functions, I swear. All right, so you can see here, it built just successfully. And we're gonna copy it over. Yep. Run defender check against it again. All right, so we'll run it here. And you're gonna see here, it's gonna come up empty. We're good to go. All right, so 2 more demos. So I kind of showed the detections kind of on disk. So I'm just gonna show you what it looks like in memory too, between the kind of normal tools and then the obfuscated tools. So we have a Cobalt Strike Beacon here on Harry Potter's machine. He executed a payload for us. Thank you, Harry. We're going to run execute assembly to run stand-in to get a list of users with service principal names that we could be able to do curb roasting on. And this is, again, kind of stand-in straight from the GitHub repo. And what you're going to see here is you're going to see we're going to get that failed to load assembly message, right? So, and again, that is AMSI for .NET picking that up. So we're going to actually go over to our victim box, look at the event log, and you're going to see the actual event log entry for that, right? AMSI for .NET picking that up. It's got the signature there. Hey, you're trying to run stand in memory, get off this box. So now what we're going to do, we're going to run the version of stand-in that we ran through InvisibilityCloak called stand up, and we're going to do the same thing just with that obfuscated tool. Again, run stand up, get a list of users with service principal names. What you're going to see here is that we're going to be able to run this no problem. So again, we got rid of the signatures, so this tool is now good to go to run in memory. Whoops. Yep, you can see there we're good to go. We're going to do this again with Rubius. So run Rubius straight from the GitHub repo to try to do curb roasting attack. And you're going to see here we got the failed to load assembly message. Again, that's AMSI for .NET picking that up. So we're going to go to our victim box. Again, this is Harry's box. And you can see there, it's got the signature for Rubius. Pick that up. Then we're going to do the same thing, but we're going to use the version of Rubius that I just showed that we did the obfuscation on with InvisibilityCloak and that kind of one manual modification as well. All right, so we're going to go ahead and run this. And what you're going to see here is we're actually going to get the SQL admin hash back here so that we can crack that and move on to do good things. So it's going to come up here in a second. As you can see, runs no problem. The last demo I have, I mentioned there are alternative options to obfuscation, right? And one of those is disabling AMSI or disabling ETW. So what we're going to do here is we are going to run the kind of normal, let me kind of bring this up. We're going to run stand-in. Again, this is just stand-in straight from the GitHub repo. And you're going to see, I'll kind of fast forward this because we kind of showed it getting detected here. We're going to get that failed to a load assembly message here. And then what we're going to do is we're going to run the same tool, but we're going to run, this is stand-in straight from the GitHub repo. We're going to use Sean's inline execute assembly with the -- AMSI flag. So what this is going to do is it's going to disable AMSI before kind of running that tool in memory. And what you're going to see is we're able to run this no problem in memory without any detections because we're disabling AMSI before doing so. See there, the tool runs no problem. And I have the same thing for Rubius, right? So I've showed Rubius get detected already. But what I'm going to show you then is using Rubius straight from the GitHub repo with inline execute assembly. So again, we're going to run it from the GitHub repo, put that -- AMSI flag in there to disable AMSI. Go ahead and run that. And you're going to see that we're going to get that hash back again, right? So all is good. So just to kind of summarize what you saw in the demos there, maybe, yes. Just to kind of show you, summarize what I showed you in the demos. First demo, we ran stand-in through InvisibilityCloak, got past those signatures. Second demo with Rubius, we ran it through InvisibilityCloak, and we made one manual modification after that to get it past the signatures. Third demo, we did similar thing with Sharp RDP. We had to make one manual modification in that method name after running through InvisibilityCloak. Demo 4 just kind of showed us running those tools in memory just to kind of show getting past the in-memory detections. And then lastly, an alternative approach to obfuscation is just disabling AMSI using inline execute assembly. In terms of defensive considerations, as far as attackers using these public C# tools out of the box, make sure that your host-based security product is fully up to date. Make sure that .NET Framework version 4.8 is installed. The reason for that being is that's when the AMSI for .NET support came. So make sure that you have that installed, so you have that capability to try to detect these tools out of the box being run in memory. And also make sure, more importantly, make sure that your whatever host-based security product you're using, whatever vendor supports AMSI for .NET in their product. As far as attackers using these modified public C# tools, as C# tools that are public out there that are modified, you need to focus on the detection of the techniques rather than the tools. So in the example of curb roasting, rather than focusing on detecting Rubius, focus on what it actually does. So for example, it has the capability to do curb roasting attack, right? Which is this number I totally memorized, T1558.003 in MITRE ATT&CK framework. So just kind of wrap things up in conclusion, detections for C# tradecraft are getting better. But there's still work to be done, as you can see. These static detections are pretty brittle, relatively easy to evade with a few manual modifications or running through InvisibilityCloak, and really need to emphasize the detections of the techniques over the actual tools themselves. If you have any questions and you're not here physically, feel free to message me on Twitter or Discord. I have my names right there. That's it. Any questions?
Two questions from online. One of them was, so the changes that you're making, do those also help evade network-based detection? So if we're transmitting the modified version over a clear text protocol, have you tested to see if those signature-based detections are also disabled similarly?
So that's a really good question. My testing, no. So I'm specifically focusing on like the host-based detection. So with something like, I'm assuming they mean kind of like an IDS or things like that. Not sure about that. But in terms of like our team, like how we use these tools, we're not kind of transferring them across the network. We're kind of loading them onto the machine in memory. But as far as do these modifications evade kind of network-based signatures, I'm not sure, just because I haven't tested that use case, because I just haven't had that use case.
The second one from online was, is there a way, or the question is, which C# tools would be good candidates for InvisibilityCloak, assuming basic low privileged user account, or failing that, is there like a way, are there certain tools or properties of tools that make this more effective or less effective?
Yeah, so let me see if I can back up these here. Maybe, yeah. Let's go to this here back. So as far as tools that InvisibilityCloak works really well with, this table here I have, so some of the tools I have there, it works really well on these tools, obviously, as of the 14th for Defender specifically. I think what properties of the tools that InvisibilityCloak provides the most value, I would say, is specifically with the strings, just because the amount of string coverage that it's getting for obfuscation is pretty decent. It obviously lacks in some properties like variable names and method names, because it doesn't do that. But I would say the biggest strength in terms of this tool, kind of using it, is, well, the tool renaming, but also the string obfuscation as well.
All right, that was it for online. Any questions in the room?
You, sir?
Where do you think that detection companies are going to focus on next, now that you've focused on those particular things? Is it string and variable names? Is it like the use of obfuscation in Auth13, or use of encryption, or like where do you think you'll evolve with your?
Yeah, so for those that are online, the question was kind of where do I see security products and vendors focusing on now that this tool's been released in terms of aspects of tools to detect and such like that, things that I can do in the future to enhance it. I think obviously the weak spot is the variable and method name. So I think if they're focusing more on variable method names, that would be a good bet for specifically this tool obfuscating. As far as the specific type of obfuscation that I'm using, yeah, I mean, you could definitely, they could obviously put in signatures for like if they have some sort of string that they have a signature for, taking the reverse of that string, ROT13, they could definitely add those signatures for sure. So they could definitely do that. In terms of other obfuscation techniques for strings, you could do something like encryption, but it's going to increase the file size quite a bit. There's a bunch of different ways you could do obfuscation other than the three that I mentioned. You could even try to stack obfuscation techniques on top of each other. So if they're going to implement detections for reverse strings and for the specific reverse strings or ROT13 obfuscated, you could take a string, ROT13 obfuscate it, and then reverse it. Or you could take a reverse a string and then base64 encode it, right? So like you can just stack these methods on top of each other, and I think that would be pretty effective.
In that case, would you just run InvisibilityCloak twice, passing it a different obfuscation? So like if you did run it reverse and then did like a base64 on the closed version. Would that essentially do what you're saying? So
the question was, to do that, could you just run InvisibilityCloak twice, like run reverse string obfuscation on the project and then run like ROT13? Not in this case, no. I would need to add support in there to actually be able to do multiple methods, because let's say you run InvisibilityCloak with reverse string, it's going to reverse the string. And then you're taking that reverse string and you're actually going to be ROT13ing it. So it's not going to know how to get to that kind of second level. Yeah. So that's a good idea though. I could add that in the tool.
This is cool. Do you have any plans to like internally have some sort of like pipeline where you're regularly pulling binaries and building it with this?
Yeah, so we actually do on our team. We do have that was an excellent question. That's the guy right there. So the question was, do you have any plans internally to have like a DevOps pipeline to kind of do this automatically? And yes, we do have a pipeline where we kind of do the automated kind of build type of thing. This can definitely be used obviously as part of that. So if you're building that on your team, we like using Jenkins in terms of like that DevOps pipeline, and that's your guy right there, Chris Spain. Yeah, talk to him afterwards. He's built some crazy magic. Yeah, definitely.
Do you want to hand me the mic?
Yeah. I think I'll just I'm done now. I'm gonna give it to Chris. Yeah, he's going to take over for the next hour or so. But yeah, definitely. And I have some friends at other companies, and they have integrated into their DevOps pipelines as well, kind of doing it automated. So pulling down tools, taking InvisibilityCloak, running through it, compiling it, that type of stuff. Any other questions? All right, thanks everybody. Oh, wait, we got one more.
So when you're talking to the code base of the tool, you're identifying, okay, you change the GUI and change some other variables and functions and whatnot. What was the basement that you hit where you realized there are only so few things that I could change, or was it just that you got version 1 out and then version more things to obfuscate?
Yeah, so the question was kind of how did I basically kind of identify the things that need to be changed? What was kind of the basic level of kind of modifications? How did I come to that? One of them was just kind of experience, kind of doing this for a while. I've done C# tool dev for a lot. I'm not a developer at all. Like I'm not a developer. I just hack stuff together and it works, right? But a lot of it was just experience with building tools and knowing, okay, like this is a part of like the project property. I can change these properties. It's not going to change how the tool works, but it's going to change how, like, I guess how it looks, right? Changing like basically these properties isn't going to affect the tool in a negative way type thing. So a lot of it was just kind of experience and just being in Visual Studio and taking a look at, like what's the C# project file? What is in here? What can I change to not break the tool type of thing? Another thing too is just like everybody's done a lot of great research already on kind of great tool dev that's out there. So just reading other people's projects, right? And taking a look at their projects and what could be changed and things like that. So, and playing with like the fender check, right? Just saying, okay, like I just pulled down Rubius, it's detecting this. Okay, what can I change in this tool, right? So a lot of it came down to just experience and just kind of playing with kind of Visual Studio and the different projects to like, okay, I can change these type of things. Other questions?
Eagles or Cobras?
So the question was Eagles or Cobras. So our team plays a lot of Halo, and the new Halo, there's like Team Eagles and Team Cobras. Always Team Eagles forever. Yeah, you know, Team Eagles forever. So, all right.
Yeah, but which armor for?
All right, now we're getting the weeds. All right. All right.
If you were to rename one of the binaries, would you name it Eagles or Cobras?
Okay, another great question. So if I were to rename one of the binaries, would I rename it Eagles or Cobras? For Rubius, I would name it as Cobras because I would want it to get detected. But Eagle, otherwise I do, yeah, Eagles. So.
I respectfully disagree.
All right. Thank you, everybody.
All right. Thank you, Brett. Very nice. Thank you.